Let's practice solving a quadratic trigonometric equation together. Specifically for this practice problem, we're going to just be focused on the solutions for this equation that fit between 0 and 360 degrees, and we will also round our decimals to the nearest tenth if we need to. Alright, so right away I'm just going to start by rewriting this equation. So we have 6 times sine squared of theta, plus we have 9 times sine of theta. They're going to want to take away 9. And that's going to be equal to 8 times sine of theta minus 7. Now to make our lives a little bit easier here, let's go ahead and make this look a little less overwhelming and use some u substitution. So we can go ahead and solve this using a quadratic pattern. I'm going to go ahead and say let's let u equal sine of theta. So wherever we see sine of theta, let's use u for now and then make a switch back at the end. So we'll go ahead and just substitute u in wherever we see sine of theta. So in the beginning here, we're going to have 6 times, and then sine squared of theta is just going to be sine of theta times sine of theta. Or we can also just write here that this is going to be u squared. Then we can write plus 9 times u instead of sine of theta, and then minus 9. And this is going to be equal to 8 times, and instead of sine of theta, we'll put u, and then we'll write minus 7. Hopefully you can already see that this is a little bit less overwhelming, at least it is for me. What I'm going to do now is, because we like solving quadratic equations when they're written in standard form or we make them all equal to 0, I'm going to start by subtracting 8u from both sides of this equation to move things to the left side. But I'm also going to go ahead and add 7 to both sides as well. So we're going to have nothing left on the right side, or we'll have 0. Alright, so after using those properties of equality, let's go ahead and say that we're going to have 6u squared, and then this 9u take away 8u, that's just going to be plus 1u, or I'm just going to write plus u, and then we have negative 9 plus 7, that's going to be negative 2, and that's just going to equal 0 on the right side. Now this is a nice trinomial for us because it is factorable, so let's go ahead and write the two binomials here. Feel free to pause if you need to go ahead and think about how to factor this. I think this is going to factor into the first binomial. I think is going to be 3u plus 2, and then for the second binomial I'm going to go ahead and put 2u, 2 times u, and then minus 1. Now let's just go ahead and see what makes each of these binomials equal 0 because of the zero product property. So if one of these binomials can equal 0, then the whole thing is going to equal 0 on the left side. So I'm going to go ahead and write we have 3u plus 2 and just set that equal to 0. If we go ahead and take away 2 from both sides, then we find that 3u is going to be equal to negative 2. And then finally we can divide both sides by 3 here. And if we do that, we can see that u would be equal to negative 2/3. Now taking this other binomial, we can also set that equal to 0. So we can say here that 2u minus 1, that's going to equal 0. So that we can go ahead and add 1 to both sides of the equation. When we do that, we're going to find out that 2u is going to be equal to positive 1. And then finally, if we divide both sides by 2 using that division property of equality, we get that u is equal to 1/2. Alright, so going back to our equations here, we can say that u is going to be equal to negative 2/3, as well as u is equal to positive 1/2. Alright, now remember what we said u was equal to. So remember, u we said was going to be representing sine of theta. So let's go ahead and substitute that sine of theta back in for u now. Okay, so by doing that, we can say instead of u, we're going to go ahead and say that we have sine of theta, and that's going to be equal to negative 2/3, as well as sine of theta, that's going to be equal to positive 1/2. Using our arc trig function, instead of saying sine of theta is equal to that ratio, we can say that the angle measure is going to be equal to the arc sine of that ratio. So this theta is going to be equal to arc sine of negative 2/3, as well as theta is going to be equal to arc sine of 1/2. Alright, now when we go ahead and plug in arc sine of this negative 2/3 into a calculator, you're going to find out that theta is going to be approximately equal to negative 41.8 degrees. But we want to remember that we're looking for angle measures that are between 0 and 360 here. So we can't go with this solution right over here. What we can do is find another coterminal angle. So again, everything is going to repeat every full circle. So we can go ahead and add 360 degrees to this. If we go ahead and add 360 degrees, we're going to end up with saying that theta would be about, I think 318.2 degrees. Now, because this falls between 0 and 360 degrees, we do like this as one of our answers. Now, what if we plug in this arc sine of 1/2 into a calculator? What we're going to see is when we do that one, and actually this one you can do probably without a calculator, hopefully, that's actually going to come exactly out to a 30-degree angle because it's one of our special 30, 60, 90 triangles. Since this angle does fit between 0 and 360, we like this answer as well. So now we have two here, two answers for this equation so far. Now, before you get too excited about finding your solutions, you have to ask yourself if there's possibly other solutions that we may be missing. I do think it's helpful to see this visually, so I'm going to go ahead and sketch the unit circle so you can kind of see what's going on here. So if we take a look at the unit circle, 318 degrees is maybe somewhere around here, and so our reference angle is going to be something that looks like this, or a reference triangle rather. And then so we have this angle measure that's right over here that kind of finds us that this 318 degrees starts from 0 and goes all the way around, so this is where 318 degrees is. Now remember, our ratio for sine is basically going to be y over r, or the opposite over hypotenuse. So when we have this ratio of -2/3, we are definitely going down 2, so it's going to be -2, but then our hypotenuse must be 3, so that's going to be the opposite over the hypotenuse. Now try to remember where the sine function is going to be negative. So remember, all of them are going to be positive over here. Just sine's positive here, just tangent's positive here, and cosine is positive here. So there's another location where we could draw this similar triangle, right? So we can go ahead and draw this triangle right over here in quadrant 3, and you can see what's going to happen over here. So if I draw this right triangle as well, and you have theta for our reference angle, then 3 is still going to be the hypotenuse, and the opposite side of theta is still going to be this -2. So whether you look at it in quadrant 4 or quadrant 3, we're going to get two triangles that we can kind of draw here that end up getting the same ratio of -2/3. So based on that, if we start at 0 degrees and made our way around all the way to here, we already have this 318.2 degrees. But what happens if we start at 0 over here and then slide all the way around to this location right over here? Looks like the semicircle part is going to be 180 degrees, and then the extra part is going to be another 41.8 degrees over here. So adding 180 plus that 41.8, we end up with saying that theta could also equal here, or will also equal here, 221.8 degrees. This right here would be a third solution. Okay, so again, for this 318.2, if we start over here at 0, make our all the way around over here, it's 41.8 degrees shy of being a full circle. And then to get the second solution over here of this 221.8, that's starting over at 0 and landing 41.8 degrees past the negative x-axis over in quadrant 3. Now what about our other ratio of +1/2? Well, we do have 30 degrees here, so that's over in quadrant 1, and hopefully that makes sense because sine is positive in quadrant 1. But if we go ahead and draw a triangle here, you can see 30 degrees, that's going to be this theta right over here. And sine is going to be what ratio? Well, sine is y over r, also known as the opposite over hypotenuse. So the 1 must be the opposite and 2 must be the hypotenuse. So we have a positive ratio here over in quadrant 1, but is sine positive anywhere else? Well, everything's positive, just sine, just tangent, just cosine. So I think we should be able to draw another triangle where sine is positive because we have this +1/2. And so I think we're going to do that over in quadrant 2. So if we go ahead and draw a triangle up just like this, you have theta again over here, that's 30 degrees for the reference angle. And if we have 1 over 2 for that ratio, opposite over hypotenuse, or y over r, then we can see here that we should have another angle measure that gets us that 1/2 as the ratio. So again, starting on the positive x-axis, we move up here. That is that 30 degrees we already found. But what if we start at 0 and make our way over here where we get the same ratio of +1/2? I think that's 30 degrees shy of 180 degrees. So 180 minus 30, I'm getting here that theta would then equal 150 degrees. And so just like that, we have a fourth solution here. So I think we have all the ones that we would have between 0 and 360. There are more that are beyond that and below that, but we wanted to find the 4 or all the solutions that happen to be 4 in this case for this particular trig equation that is in that quadratic form. So let's just go ahead and put this all together. So we can go ahead and say here that theta is going to be equal to, and let's put all 4 of these solutions in there. So we had this 318.2 degrees. We also had this 221.8 degrees that got us that same ratio. Then we had that positive 30 degrees, and then we had this 150 degrees that also gave us that same reference angle of 30 degrees. This right here would be our 4 solutions between 0 and 360 degrees that make that quadratic trig equation true. Now that just about wraps up this video. If you found it helpful, please consider giving it a thumbs up and sharing with a classmate or friend who might also find it helpful. And as always, keep up the great work that you're already doing, and I'll see you in the next one.